Hello everyone, my name is Oshan. Today I'm presenting on energy efficiency, minimizing the environmental impact of AI chips. So, why energy efficiency matters in AI? AI is growing fast and it's using a lot more energy. This creates a big problem for the environment because it leads to more carbon emissions, which contribute to climate change. For example, training one big AI model can release as much as carbon as 5 cars do all their whole lives. Also, simple AI questions like in chatbots use about 10 times more electricity than regular online search. By making AI chips, the hardware that runs AI, more efficient, we can cut down on this energy use. This helps make AI better for the planet and allows it to grow without harming the environment as much. Now, let's look at where most of the energy gets wasted in AI chips. First, there's the memory bottleneck. In most chips, memory and processing are separate, so data has to move back and forth a lot between them. The moving uses a ton of energy and is a big part of the total power use. Second, AI work involves billions of simple math operations like multiplying and adding numbers. Even when done in parallel, each one needs energy, so it adds up quickly. Third, these powerful chips get really hot, so data centers need a big cooling system. About 40% of data centers' power goes just to cooling, not the actual computing. Now, let's talk about the current power-saving approaches in AI hardware. There are some ways to save power in AI hardware right now, but they are limited by the basic design, where memory and processing are kept apart. One method is DBFS, which stands for Dynamic Voltage and Frequency Scaling. It basically adjusts the chip's power and speed based on what's needed at the moment, saving some energy during quiet times. Another is power gating, which turns off parts of the chips that aren't being used, cutting down on wasted power in those areas. Then there's backside power delivery, which sends power to the back of the chip instead of the front. This reduces losses from wires and can save a lot of energy. Neuromorphic chips are inspired by the human brain and only use power when something happens, like an event. They are still mostly in testing but could save huge amounts of energy. To really save more, we need to change things up by doing the computing right inside the memory. Now let's talk about the IBM's analog in-memory AI chip, which is a big change in how chips work. It fixes the memory problem by doing the math right where the data is stored. The key idea is using phase change memory, or PCM, which stores the AI model's data and does the math operation at the same time. Here's how it works. You send input signals as voltages to rows in memory array. The outputs comes as currents that naturally give you the result of the math like multiplying the data by the inputs. The big win is no more moving data around between memory and processor, which cuts energy use and speeds things up. So, how does the chip actually save power? First, there's no data shuttling. Everything happens inside the memory, so you avoid wasting energy on moving stuff back and forth. Second, it needs smaller support circuits and less switching, which means lower overall power use, both when active and idle. Third, the memory arrays do many of these math operations in parallel using analog signal, which is more efficient. The result? It gets about 6.7 trillion operations per second per watt, compared to GPUs, which is around 0.5. That's a huge improvement. Now let's look at the impressive result and benchmark of the IBM analog chip. It reaches about 6.7 TOPS per watt on average, with a peak of 12.4 TOPS, means tera operation per second, basically how much work it does. That's roughly 14 times better on energy than top GPUs for the same job. In real tests, it handled tasks like spotting keywords in speech and transcribing audio, doing it faster and with way less power, while keeping the same accuracy as GPU systems. Why IBM's analog in-memory chip is a game changer? Why is this chip is such a big deal? It breaks the old bottleneck by combining memory and processing, so no more wasteful data transfers. It works well for real AI tasks like speech or image recognition, not just simple stuff. It helps make AI greener by cutting energy needs for training and running models. Plus, it's a model for future chip that could use even less power. Here's a quick comparison of different ways to design AI chips based on a table. We have DBFS, with medium power saving using ARM CPUs and NVIDIA GPUs. Power gating also medium in Intel CPUs. Backside power delivery is in high savings in upcoming TSMC 3nm chips and Intel 18A. Neuromorphic event-driven chips have very high savings like Intel Lohi and Intera Pulsar. Analog in-memory computing is very high too, like the IBM analog AI chip. Overall, the newer ideas like neuromorphic and analog save way more power than all the tweaks. So, in conclusion, AI's energy use is a big environmental challenge as it grows. Regular methods like DVFS, power gating, backside delivery, and neuromorphic chips give some savings, but IBM's analog in-memory chip is a breakthrough. It competes right in memory, fixing the separation issue, uses phase change arrays for lots of parallel work, and gets about 14 times better efficiency than GPUs. This matters because it makes AI more sustainable, scalable, and better for the planet. So here are my references. Thank you.